Hey there, I'm Ken. This is Canadian Retro Things. Welcome. It's time for part 2 of the Robert Kilgus interview. This is part 2 of the Robert Kilgus interview. If you haven't seen part 1 yet and you're interested in his early years of being involved in computers before Radio Shack, then the link to that video is in the description. This video is going to be covering his Model 1 years when he first started working with Radio Shack. So let's hop right back into that interview. Hey there, this is Ken. This is Canadian Retro Things, and today I'm in Flint, Michigan doing an interview. I'm sitting down today with L Curtis Boyle and Bob Kilgus. You may recognize the name from some great CoCo games of the past, such as Dino Wars and Skiing. But because this is going to be a in-depth interview and I want to make sure everything goes perfectly, I'm not going to be sitting here. Curtis is going to be doing the interview, and I am going to be behind the camera.
And
lo and behold, in 1977, this started to happen.
Yep, here along, all of a sudden, the dream comes true. There is a machine that's all put together with everything I need. A Radio Shack, a pet, and an Apple. I had just finished paying off the debts from my first marriage. I had enough money, but at the time, it's a big investment. The pet, with those little chiclet keys, that's a toy. Apple, they can go sit around drinking their wine and playing their fancy.
Yeah, it wasn't for poor people.
No,
for sure.
it was more expensive. Radio Shack, hey, now that looks like an actual keyboard they've got on that. And Radio Shack's been around a while, and price was expensive, but I could handle it.
Yeah, but way more, for like half the price of an Apple, too. So.
Yeah. Well, I put down my, what was it, $50 or $100 deposit as soon as I saw that and made my decision. And what was that, 87? 88?
77 is when they announced it in August, I believe.
Yeah.
And then they didn't actually start shipping for months. But
right. And I got my delivery in January of the next year. So it must have been 78 that I got my first Radio Shack computer. And there I sat in my little 3-bedroom bungalow, 900 square foot house. And on my dining room table, I had a computer with a 1 megahertz clock. Gee, that mainframe that I first had experience with Burroughs had a 1 megahertz clock. And right behind it here, I've got an expansion manual or expansion module with a bunch of memory on it. And you know, it's got more memory than that mainframe had just on my desk here. And a cassette recorder. I've got an I/O device.
That's your tape drive from the mainframe.
That's the tape drives. I got myself a mainframe computer sitting right on my table. So I started figuring out how it worked. I don't just want to know what it does. I want to know how it does it. So I started taking advantage of the peek and poke and did a bunch of snooping around while waiting for an assembler to come because I couldn't do any real programming. Basic, yeah.
Yeah, I think you mentioned it was like a couple of days. Oh, that's enough of that.
Yeah. I played around with the basic, and I got it to start making numbers scroll on the screen and that kind of stuff. But I wanted to do some serious programming, and to do that, I don't need basic. I need something where I can get into the guts and make it do the maximum that it's capable of.
And I think at that time you might have had little monitor programs and stuff, but that was it. You had to do hand assembly and thing else. So that would wait for an assembler, I assume, just to make it a lot easier.
No, I didn't have any assembly at all.
Not even a monitor?
No, just
the basic ROM and that's it?
Just peeking and poking around. I'm not sure what documentation I had, but I did have the machine language available to me, probably in a book that I bought, but I don't remember much about that.
Now, you mentioned that you were, the megahertz speed was the equivalent of what you had back in the Burroughs days. Now, you'd also mentioned you learned assembly language on the Burroughs. How did the Z80 compare for what you were used to?
Well, to start with, back in the 60s, we were talking about 6-bit characters instead of 8-bit bytes. So the whole orientation was different. The memory in the mainframe computer was organized in 48-bit words consisting of 4 16-bit
Chunks or something?
chunks.
Yeah.
Each one of those 16-bit chunks could be an instruction, a machine language instruction that would contain that's 12 bits. The first few say which operation it is, and the rest of it can be part of,
like an offset, an
Yeah,
index,
like an
what
index.
register you're using.
Yeah.
Yeah.
Anyway, a completely different arrangement, and the programming techniques were quite different from. Yes, it had registers. I don't remember all of the registers it had, but it had the usual register to point to where the instructions are coming
program
from,
counter.
work registers, address registers where you're storing things and getting things from, and
So it was different, but not so different it was alien.
yeah, I mean, I understood the general concepts, and they were all the same general concept of machine that's being given instructions that moves things around in bits and bytes and words and characters, whatever, moving information around and changing it, doing things with it, storing it, whatever. So in that respect, I could learn the Z80. It took me all of a couple of weeks to learn the machine language on that. And when the color computer came along, it took me all of 2 weeks to figure out the difference between them and be able to program proficiently on a different processor.
Yeah. And you'd already gone through several mainframes and stuff, so you were kind of used to switching between character sets, between banks and stuff too, weren't you?
Well, it's the same machine, the same, even at other banks. By that time, the programming was being done in a higher level language, COBOL.
Yeah, right.
So it didn't matter whether they had a Burroughs machine or an IBM machine or something else.
You're using a common higher level language.
At that point, all of the commercial programming that I did was in COBOL. I had learned a bit of Fortran while at Burroughs, or was that Elgol? Anyway, never used it much. I learned reverse Polish notation and all that kind of stuff.
Yeah, like fourth. So you got the TRS-80 Model 1, or it wasn't called the Model 1 back, it was just the TRS-80, and you started learning some of the assembly language stuff from the Z80 processor, etc. But one thing you did figure out is how sound worked through the cassette port. And I know from talking to you earlier, and also I think from Boise, it sounded like you had actually sent a sample of the program, or sample of the sounds itself, I should say, to Radio Shack to say, look, I managed to generate this, and then that kind of linked you up into eventually creating software for them and meeting Van Chandler. So I was wondering, how did that whole story happen?
Well, I was poking around one day when I found the place where the programs were saved to cassette tape, and I found the routine and noticed that they were poking various values into a particular memory location. So I poked a few values in there to see what would happen. And I found, oh, well, that one starts and stops the tape recorder running. And then I finally figured out that a particular bit in there would change whether it was recording a positive or a negative number to the recording head, to reverse the polarity of the magnetism from the head. And I could see that they were starting the tape moving and then counting and recounting in loops to let a certain amount of time go by, and then start transferring data. And the data would be transferred a bit at a time, and for each bit, it would set the magnetism one way, count for a certain length of time, and then stop. And I finally figured out that how they were doing that and controlling the head on the tape recorder. And so I started playing around with it myself and putting in a little loop to count different periods of time between changes in the polarity of the signal, and do some recording on the tape myself. And when I played the tape back, I found out that if I set a very short delay, I was getting a nice high-pitched tone coming out on the tape recorder. If I set a longer duration and made the changes over a longer period of time, I'd get a nice low tone. So it wasn't until I got the assembler that I was able to actually do a significant program, but I took advantage of that knowledge and went after that particular capability of controlling the tape recorder, and I found out what the minimum weight between changes of polarity. Frequency would go higher and higher and higher until a point where it was too high to really understand that it's a tone,
Yeah.
and lower to the point where it was just clicks. So I know I can make usable tones in between a particular range. So I went out and I bought myself a little pitch pipe and played around until I got a note on the scale, and ended up making a little table of values of how much delay
A C sharp would take or something.
Yeah,
like that.
exactly. The length of time to play each of these notes in the scale. And okay, now I can play any note I want. Now what if I want to play a whole bunch of notes? I want to put a musical score in there. So I wrote a little bit more, and so that I could type letters on the screen and have my program say, oh, you want a C? Okay, that C translates into this entry in a table of values. C and a number, B and a number, A and a number, E and a number. So that all I had to do is look at the letter on the screen and pick out a corresponding number, and that's the delay between reversals in order to create that
square wave tone.
To create that tone. And what do? You add number after that, and you've got a duration. So, okay, I've got a pitch and a duration, and the duration is how many cycles of
the
how many changes do you make in order to get to that duration. So it didn't take too long before I had things set up so that you could type in a musical score as a series of letters and numbers, and blanks for rests or whatever. And so I typed out a tune. I don't remember what tune it was. I made a few tunes, recognizable music, and had it play out onto the cassette tape. And my wife says, why don't you send that off to Radio Shack and see if they're interested in it.
This is your second wife, Peggy, we're talking about.
This is Peggy, yeah. She said, well, this was in 1978, and the divorce from the first one was in '69. So Peggy was the inspiration. She convinced me to contact Radio Shack, and don't just give it to them. Show them what it can do and see what their reaction is. So I ended up mailing just the cassette of the output.
The actual music itself.
Yeah, you could put it in a tape recorder and play it, and what you're hearing are square wave tones, a little bit harsh because it's just a square wave, but a recognizable piece of music. And a letter explaining to him that I had written a program that allows you to create a score on the screen and play it through the cassette tape output, record it on a tape, and then you could play back the tape and hear the music. And, well, it got some attention, and I got a letter back from Van Chandler with a non-disclosure agreement that he had signed so that I could safely and comfortably send him a copy of the program.
Rather than just a sample
Rather
output.
than just a sample of the output. So that was the first contact that I had with Radio Shack, and they ended up not only buying that program on a royalty basis, but also they realized that there was more you could do with the output to the tape recorder than just put it on a tape recorder. And it wasn't long after that you would notice on the Radio Shack catalogs they had a plug-in amplifier with a little speaker that you could plug in there. And then you could play your music and hear it right then and there, instead of having to record it and then play back the tape.
Yep. And then later people took advantage of writing games and stuff that do with sound and stuff. That was how it was all done too. So kind of based on your inspiration.
I showed them that it could be done. And it didn't have a sound chip in it. It had a tape output.
Yeah.
And
a digital, just a 1-bit one too.
Yeah, very simple, but amazing what you can do with a bit.
Now, out of curiosity, since Peggy's one that kind of inspired you to send the sample, and then you ended up getting your first contact back as a non-disclosure agreement, so obviously they were impressed. Were you surprised at the fact that you actually got offered a contract right from just having sent sound samples, or were you pretty confident that you had something pretty cool going here?
Well, I knew it was unusual, and it was worth the risk of trying to do something with it. I'd mentioned it to people at work, and they'd say, "Oh, well, wow, if I got that, I'd be so happy if they would, if you could get a deal that they would maybe send you a tape drive or a memory expansion or something like that. That would be great, you know." Well, I ended up getting a rather good amount of royalty off of that program. And the way they were doing their bookkeeping at the time, it was hit within just a couple of quarters. So between that and a second program.
Yeah, which we'll get into in a second. Now, the program we should mention, we haven't even mentioned the title of it yet. This was called Micro Music.
Right.
And I was wondering, did you choose that name, or did they choose that name? Do you remember?
I suspect they did. I don't have a clear recollection of giving it a name myself. I had a program that would play music, and that's what I sent, was a program that plays music on your Radio Shack Model 1. So I strongly suspect they came up with a name.
And did they, like, once you sent in the program, did you guys go back and forth with quite a few changes, stuff they wanted, or they pretty well accepted it as is? Because this is early on when they were still learning what they wanted in software too.
Well, there was very little that you could do in the way of making changes to it.
Even just interface or something like that.
No, the display that was available was nothing but a limited number of characters that could be displayed on the screen. You had plenty of room for a musical score, being nothing more than a series of letters and numbers.
Yeah, which is the table look
right.
Up. So yeah.
Oh, and I wouldn't be surprised if I had parentheses in there or something to indicate repeats. But no, it was just pretty much straightforward, and took me all of about 6 weeks to write. And about the same as most of the programs in that era.
Yeah. And the second one you did was part of the Micro series, I guess, because it's called Micro Movie. This is another one. This is where you're actually doing, now the graphics capability of the original series was a bit limited. It's 120 by 64, I think. Black and white in groups of 2 by 3 pixels. But you actually wrote an animation, basically you create character cells just like a Disney animator would do, of drawing little bits and then cycling through them to animate. Right. So what was the prompting inspiration for that?
Well, I wanted to just do something simple like draw a line on the screen. And the only means available to put information on the screen was using their character set. And each character covered a particular area of the screen that was 2 by 3 pixels. And for graphics, they had like the uppercase and lowercase. Uppercase is letters. Lowercase are 64 different combinations of which of those bits are on and which are off. So, okay, yeah, you could do it that way, but that's painful, having to try to figure out, going from one character cell to the next character cell, and you want to draw a diagonal line. What character puts this one, and this one on here, and it's an entirely different character next to it to continue the line down? It was just far too cumbersome for anybody to try to do anything with graphics on that. So I said, there's got to be a better way. And when you go into machine language, you can do anything. You can just do anything. So I figured if I went into an assembly language program, I could figure out how to get a particular bit to flash on and off by alternating between 2 characters that cover that particular area. Yep. And use that as a cursor and be able to use the arrows on the keyboard to move that cursor around the screen. It worked beautifully, and you could push the enter key and there you got that point set on the screen. Move it with the arrow somewhere else, push a key, set another point. You could draw, freehand drawing of anything you want on that screen without having to know all of the difficult programming you would have to do in BASIC in order to get even a straight line drawn across the screen.
Yeah, because BASIC just had set and reset. Basically, pixel on, pixel off, that's it.
Yep.
Yeah, and it was slow. Yeah.
So I've managed to get it so that you could draw anything. And then I said, well, it's nice to have pictures, but there's got to be more you can do than just have a picture. So I've realized that I had enough memory that I could take a picture and save it and start modifying the screen and change things and create a second picture that is a slight difference from the first one. And then set that aside and get another one and make like a flip book.
Yeah, flip book cartoon type thing.
Right.
Yeah.
Only there's how many of those frames can you save?
Yeah, because this is back when you had 4K and 16K, like not a ton of RAM.
There isn't that much memory available, so I had to come up with a way of data compression. And basically, you take a word, clear it to zeros, and you look at the screen and you have a saved previous screen. And you go character by character comparing. And when they're the same, you start counting up this counter over this side over here. When you get to one that's different, okay, at that point you take this word and you save that word.
Which would be how many pixels have not changed?
Right. How many characters have not changed, and then you start counting the characters that have changed as you copy them in, and go back in that first byte and indicate how many new characters follow. Yeah. So that in a one-word thing you say, just leave this many characters alone and then copy the following so many characters, and then another word would show up with the 2 counts, then how many were the same and how many are new. And it's a very effective compression technique.
It's basically called run length encoding now. It's yeah.
But
so on a 16K machine, how many frames of animation could you fit, do you think, just for an average? It obviously depends on the complexity of the changes.
It entirely depends on how spaced things are and how much has changed from one frame to the next. I mean, if you've got a whole picture of a garden with a whole bunch of trees and flowers, and there's one flower in the middle that you want to grow up and bloom. Well, all of that stuff out there is just a handful of bytes to say that it's all the same as the previous screen. Just a little bit that changed in the middle is all that you have to really save. So depending on how you make your
complex,
pictures
yeah.
and how much is different, it's going to determine on how many frames. It's remarkable how many frames you can generate.
Yeah. Now, when you were doing this, did you want to do it just because you wanted to see animation, because you thought that was a cool thing to do, or were you thinking of video games already at this point? Because video games in the arcades have been going for a few years by this point, which of course are based on moving stuff around on the screen.
Generally, a lot of the things that I do are because I want to do something and it won't let me do it. I gotta write a tool that will make it possible for me to do that. I wanted to be able to do something with graphics, and the machine couldn't do it for me, so I made the machine do it. It's as simple as that. That's the motivation. Self-satisfaction, self-need. I needed that tool. I built the tool. Other people find it useful? Great.
I will mention, just for the viewers here too, because Ken's still behind the camera here, but we've actually managed to pick up a copy of this with the original tape sold by Radio Shack that Ken will be actually getting into this summer. So we'll actually be able to see your program in action. So that'll be cool for into the thing here. Now this is another one you submitted to Tandy yourself.
Right.
And this one, because they already knew you from the micro music, I think this went a bit quicker as far as turning it around for publishing it.
It was the same procedure pretty much, except that we had a non-disclosure agreement. They're not going to go blabbing and giving away my work, so I can send him the program itself this time and with confidence. And after talking to him on the phone, I talked regularly with Van about the work that I was doing, and when I told him about that, send it on in, let me see what we got. And
he liked it in the way it went.
The rest is history.
Now, one thing that I was mentioning the Boise interview is that your next program, this was the first time it went the other way around, where they actually requested you to write something for them, and this was the cross-reference utility. Do you remember if that was Van Chandler himself that asked you for that, or was that maybe...
Almost certainly. I'm almost positive it was Van. In one of my calls with him, I'm pretty sure it was even on a Friday. I used to talk to him regularly on Fridays, and he said that they really need a cross-reference utility for basic programs.
Yeah, just for those who don't know what it is, it's basically the cross-reference utility will end up showing you, and you can pick which options you want, but you can have the line number, what basic keywords show up in that line number, what variables are referenced to that line number, et cetera, so you can start cross-referencing like what subroutines are actually using this variable, which ones aren't, helping you debug, et cetera. So it was a really valuable utility. But it was the first one they actually asked you to do. And I was wondering, like you mentioned in Boise's interview with you, that you actually completed this program after being asked to do it in 3 days.
Yeah.
And did you actually end up like writing the manual yourself in that 3 days as well, or did they give you a pretty clear idea, this is what we want, just can you get it working?
Well, it's pretty much self-explanatory. I believe they had menu selections on the screen, and you just it read a program in from cassette tape and did its thing and displayed the results on the screen, as I recall.
Yeah.
And you could stop or interrupt the playback on the screen as you're going
and you could turn the different things off. I don't need variables, I just need the line number references or something like that. So, but did like the interface you said, like it's pretty self-explanatory screen, is that something you came up with, or is that something they said, here, we want it to look like this, and can you do the programming?
Well, there was no direction on what it was supposed to look like, just what it was supposed to do. And it was supposed to give a programmer the capability of having that information made available to him by whatever means you can do it. And so I figured out how to do it, and I did it. And this was a Friday that he told me about that, and I was still a commercial programmer working at that point in time,
this is just like a side hobby at this point.
Yeah, up to this point, I'm still working at the truck maker, Diamond Reel, or I'm pretty sure that was then, and so I took the weekend off, as it were, I didn't have to work on weekends. So over the weekend, I wrote the program. And from the time he gave me the call on a Friday, and the next Monday, I'm pretty sure it was, that I had it in the mail.
Wow.
And I don't recall ever having to have it come back and make any changes to it. It was
just worked out the gate.
Just done. I did take advantage of tables of information in ROM, of the basic ROM, that gave me the names of the verbs and such in basic, and so that I could utilize that as the basis of what I was going to be looking for.
Yeah, like with the variable structure pointers, you can find out what the variable name is. And,
right.
So the next project you did for Tandy, and this one took you some months to develop. This is one of the longer ones. And it was based on some experience you'd already had with the Burrow machines and how the operating system stuff worked. And this is, of course, microfiles, which is your pride and joy. And this is one that actually, if anybody wants to complete full details of this, you've actually published a book that you can order on Kindle, I believe. And it's like 400 pages explaining how this whole system works. We're going to broad stroke it here because we could be interviewing for hours on this alone, I'm sure.
If you're a Z80 programmer, you'd be able to read and understand it all. If you're not, well, at least I put it out there so somebody can see what it was like.
So basically, I wanted you to explain, like we're going to get a little bit of technical detail, like what basically the program is doing under the hood type thing. But what was the purpose of the program to you, and what stuff did you borrow from your mainframe days that helped make it happen, programming?
Well, one of the things that I latched onto from the mainframe days was it had true multiprocessing and true virtual memory. That is, it would dynamically allocate memory as program requirements called for it, and it would save things onto what at that time was a drum memory, and temporarily and as treated as if it's extra memory. And the key to it working was that each program had something they called a PLT, a program locator table. And it is a single contiguous hunk of information that all other parts of the program reference data and other parts of the program through that table. That table says where those parts are. You've got a subroutine, you call it by going to that particular entry in the program locator table. You've got a record buffer that you're going to be putting information in. You go to that program locator table, and that tells you where it's located in memory. And the way it worked was that every entry in there, they were 48-bit words, but the high-order bit was called the presence bit. And what would happen in hardware, when you load a word into memory or into a register, if that presence bit is off, it sets off an interrupt. And the interrupt routine looks at where that code was, what they were doing at the time, what they had loaded into the register that caused the interrupt, and oh, that is a pointer to a particular piece of data. And if the data is not in memory, the information in that word says where it is, relatively speaking, within the program itself, where it was born on disk. So if it's not in memory, it goes to the program file and it reads that, or it finds a place in memory to bring that piece of the program and put it in memory. And once it's in memory, it takes the address where it put it and it replaces that in that word in the program locator table.
So it's kind of like virtual memory is used nowadays.
Yeah, exactly.
Swaps to disk.
It was virtual memory.
Yeah.
And I couldn't very well do that on the personal computer because I couldn't get a load of data to set off an interrupt.
I know.
So instead, I made it so that you could call a function, and that function would load a register with some information that you want to put in the register. And when I put the information in the register, I examine it and look at the high order byte in that 3-byte address that you put in there. And if that first order byte is 0, oh, that is an actual memory address. The low 2 order bytes, that's the address in actual memory. Yeah. If it's not a 0, well, then that's the number of a separate independent data file on the hard drive, or on the diskette rather, and the information you want is out there. So this gave me the ability to address, as if it were memory, real memory, and any number of additional data files, each one treated as another block of 64K of memory. Each separate file on the floppy drives was assigned a number, and that becomes the high order byte of a 3-byte address.
Okay.
And then my subroutine would detect whether you're trying to go after real memory or whether you're trying to go after something in virtual memory. And if it's in virtual memory,
it knew how to look it up and grab it.
It can look it up and grab it and put it into real memory. And when it goes into real memory, that reference pointer gets the real address put into it.
Yeah, so it changes the first byte to a 0 to say this is now real, and here's where it is in RAM.
Exactly.
Yeah. And then you actually had to be able to do program segments and stuff too. Like you could actually have programs that were a bit bigger than memory, that where you could say,
right,
I need this routine now. Right. It's in virtual memory, go load that.
Right. Now your application program shows up as another one of these data files out there that can be up to 64 bytes, 64K long, and application program always has an 01 as the high order byte in its address.
Okay.
So 01 always refers to the application program that initiated the process. And other numbers are used for memory extensions. Other numbers can also be used for additional program extensions. But the program would then have to know that to access those other areas, it would use a 3-byte virtual address that started with a different number that you assigned.
Yeah, and this is something you called VDOS, this kind of virtual DOS.
Yes.
That you came up with. And you we'll get into this shortly here, but you also kind of brought that over to the CoCo with color TRS-DOS a little bit later too.
Right.
So,
well, the thing is, I wanted to write a program that I knew darn well was not going to fit in this personal computer. It just wasn't going to happen, because I wanted to do things like allow the user to talk to the machine and use ordinary language to tell it what you want to do. I want to build a file for my record collection. Build file record collection. In there, I want to know the name of the artist, the label that it's on, the date that it was released. So make records containing name, date, artist. I wanted to be able to work with ordinary language input. And I knew darn well that kind of programming was going to take a lot more coding than what you could normally put in a program that you could load in a 16 or 48K, or even, you didn't really have a 48K machine. You had, yeah, you did. But you couldn't do all that and still have room to do anything else. So I said, I've got to have a virtual machine in order to be able to do the kinds of programming that I wanted to do. I needed the virtual operating system. I needed to have virtual memory, and I needed to have dynamic paging in and out, and I needed my programs to be bigger than what will fit in memory. Yeah. So that's the motivation that got me to write VDOS.
And that's also the reason it took you months, because you did the whole VDOS film, then you went into doing microfiles.
Yeah.
And that was just kind of like a showpiece for the VDOS system.
Yeah, I wanted to write this microfiles program that did data management on a much more human level, and tried to explain to Van Chandler my virtual memory operating system was, and he had no clue what it was I'm trying to tell him. I mean, who ever heard of such a thing as virtual memory in a personal computer?
Especially at that time period,
Yeah.
78, 79.
So a lot of my inspiration comes from my own personal need. I want this machine to do this for me.
Yeah.
So
and your background in mainframes also enabled you, because you knew what some of the big iron was capable of doing, and you knew what was possible if you figured out a way to do it. Whereas somebody coming in, like us teenagers and stuff in the day, we had nothing to fall back on. We didn't know what virtual memory was. We'd never seen it before. Never even heard of it. So it's not like any of us could afford a mainframe. Yep. Okay, so a bit of a correction to a little earlier here. Bob has graciously agreed he's going to make a HTML version of the book inside Microfiles, which kind of explains the whole virtual DOS system and how you got the whole program and stuff working and everything you went through doing that. Now, if you want to support Bob, please feel free to go onto Amazon and purchase it. It's available for Kindle, etc. It's a way to throw a few bucks your way for doing it. And I should mention, it's over 400 pages and includes source code bits and explanations.
Most of those pages are scanner copies of the original listing.
Yeah, but plus your explanation of why you chose to do certain things, etc.
And then there were a considerable number of pages going into detail, and within the descriptions I have hyperlinks to the pages of the listing that cover the particular topic I'm talking about.
Yeah, if you want a really good deep dive on how to design a virtual operating system, or virtual DOS,
memory.
virtual memory on a machine that doesn't technically support it, it's an excellent read. I've only read a tiny bit of it myself so far. Now, we're going to go back just for a second here, because one thing that you mentioned when you were getting interviewed with Boise back in 2013 is that your way of getting paid by Tandy for royalties on your programs changed, because they were just figuring themselves, like, how do we do this? So at the beginning, I think the first two programs you did, the micro art program and the micro music program, basically you were paid a royalty on copies shipped. Now at this point, Tandy was shipping stuff to all the stores, so that was a shipped product. Yep. And then they changed to copies sold to a final person. So how did that all happen, and how did you feel when the change happened?
The original contract called for a certain amount per copy, and it didn't explicitly say sold or
like sold to store or sold to client.
Sold to a store or sold to a customer or whatever. It just said per copy, as I recall, and every quarter I would receive a royalty check for the number of copies. And I was really surprised because, they got, 5,000 stores out there, and just sending one copy to each store. No wonder there's 5,000 being paid for here. And there was a maximum dollar amount on the royalties. So the contract was good up to a particular maximum. And lo and behold, within just a couple quarters, we hit maximum on micro movie and on micro music. And that was a good hunk of change. And Peggy and I, being very conservative and accustomed to living on very little, we just had most of that money just socked away in the bank. And it basically amounted to a year's worth of living expenses if I were to quit and go to work for myself. So, maybe I can make a living off of this freelance work. So a point came that I decided, we don't have kids to worry about. We never had kids. So let's take a chance. I'll quit my regular salaried job and we'll go it on my own. I've got this program called Microfiles in the works that I'm working on, and if I quit my job, I'll be able to get through that a little bit faster. And I'm pretty sure we can get a lot more off of that than we can out of those two programs. So I quit my job, and about 1 week later, the next up royalty check arrived. And we sat out on our front porch, opened it up, waiting for the inevitable surprise of how much we made this time. Wow! And we looked at it, looked at each other, and just couldn't stop laughing. 50 cents! 50 cents! What the heck was going on? Well, the cover letter explained that their bookkeeping methods have changed, and instead of being paid on copies shipped to the stores, you'll be paid for copies actually sold to a customer. Well, duh, that's no surprise, but why didn't they warn me before I quit my job? And what am I going to do with 50 cents? And I decided, you know, I don't care. The 50 cents doesn't mean anything. I'm going to deposit the damn thing and let them pay for the process of having it processed. At least get that much satisfaction out of it. And Peg never forgave me because she wanted to keep it as a souvenir. I suppose that would have been a little bit more. I could have showed you here. I got a 50-cent check from Radio Shack. Isn't that great?
Yeah, I guess that's kind of before Xeroxing machines and stuff were that common. You could have made a copy of the check and done it.
Nowadays, people just use their cell phones.
Yeah.
I used a scanner for microfiles, listing all those, trying to get that fan-folded listing on that scanner bed, and taking a picture of a page of 14 by 7/8 and 11.
So once this the way of paying you had changed, then it basically had to play catch up, right? How long did it take you to start getting decent royalty checks again?
Well, some of them never paid anymore, but I did continue writing programs, and the new ones that I wrote, I started earning money on, especially when the color computer came along.
Yeah, which we're about to be getting into very, very quickly here. So basically, Tandy then started a thing called Project Green Thumb, which originally was going to use a TRS-80 Model 1, which is what it was called by this point, keyboard, and it was going to be a thing for farmers to check in for, doing stocks and all kinds of things. And they were comparing with this in '78, and they were working with Motorola on the chipset for it. They're going to use a 6809, the video display generator chip, which you already had out at this point. And they did a small run. This wasn't involving you at this point.
And that is the Model 1 years of the interview with Robert Kilgus. This is particularly exciting for me because pretty soon I am going to be having my hands on a Model 1, and I'm going to be able to play with a bunch of those programs because I believe a bunch of them are included with this little lot that I'm getting. So that's just a sneak peek on some upcoming videos for me. Anyways, thanks for watching. The next video will be coming out in a couple of days, and it will be covering the early CoCo years. Alright, yeah, I hope you enjoyed this video. If you did, don't forget that a like, a subscribe, and a comment below are all things that help the channel out a lot and are greatly appreciated. Until that next video, see you later.